All right, our last little bit of fun for the sum and difference identities are those for tangent. So we have two of them. We have tangent of alpha plus beta is equal to tangent alpha plus tangent beta, all divided by 1 minus tan alpha tan beta. And we have the identity for tangent of alpha minus beta, and that's equal to tangent of alpha minus tangent beta, all over 1 plus tan of alpha tan beta. Let's use one of these for this example. Determine the exact value of the expression, and the expression being tangent of 11 pi over 12. So my goal is to write, I'll do a little work on the side here, is to write 11 pi over 12 as the sum of two angles. Now I can do that. I can say pi over 12 plus 10 pi over 12. Now the problem is pi over 12 is not a nice angle on the unit circle, right? So we're starting with 11 pi over 12, not some nice angle on the unit circle, but neither is pi over 12. So this isn't really like helping us or moving us forward in the problem. So we try something else. Maybe we try 3 pi over 12 plus 8 pi over 12. So we know this equals 11 pi over 12. But again, only helpful if each of these correspond to an angle that we actually know something about on the unit circle. So this is pi over 4, and this one is 2 pi over 3. So 3 pi over 12 is pi over 4, and 8 pi over 12 is 2 pi over 3. Both of those are known angles on our unit circle. Okay. So we get one here and one there. So we are going to use this. So we're going to say tangent of 11 pi over 12 is the same as tangent of 3 pi over 12 plus 8 pi over 12. And the only reason we're doing that is because now that is the tangent of pi over 4 plus 2 pi over 3. Okay. And we want to do that because we have this nice formula. So we're going to say pi over 4, you're playing the role of alpha, and 2 pi over 3, you're going to be playing the role of beta. And then we're going to use the right side expression here in this equation to write this out in terms of tangent of just alpha and tangent of just beta. So I'm going to have tangent of pi over 4 plus tangent of 2 pi over 3 all over 1 minus tangent of pi over 4 tangent of, 2 pi over 3. Okay, so when I do that, now I want the values for each of these. So tangent of pi over 4 is 1. Tangent of 2 pi over 3 is negative root 3. So we can get that by using the unit circle. Then we get 1 minus tangent of pi over 4 is still 1. And tangent of 2 pi over 3 is still negative root 3. So if I multiply this out, or just simplify, I guess, 1 minus root 3 all over 1 plus root 3. And you might have a teacher who's kind of a stickler and says you cannot leave a radical in the denominator. If that is the case, we can multiply this fraction by a version of 1 that looks like 1 minus root 3 over 1 minus root 3. And then we have to kind of FOIL the numerator and FOIL the denominator. So let's see what we get when we do that. Okay, so we get 1 minus root 3 plus 3 all over 1, and then minus root 3 plus root 3 minus 3. So what does this come out to be? Well, it comes out as 4 minus 2 root 3 all over, the radicals cross out in the denominator, so it just leaves us a negative 2 in the denominator. Now, we can actually take each term and divide it by the negative 2. So 4 divided by negative 2 is just negative 2 minus 2 root 3 divided by negative 2. Okay, that just gives us negative root 3. Okay, so this just becomes negative 2 plus root 3. So if we go all the way up, what we found is that we can find the tangent of 11 pi over 12, right? This angle not being on the unit circle, by breaking it up into two angles that we know on the unit circle, and then kind of assigning them, right, one as alpha and one as beta, and then using the formula, because what the formula does is then takes this value, tangent of alpha plus beta, and puts it into the individual tangent values, which we can find using the unit circle or some that you may even have memorized. And our answer is negative 2 plus root 3.